Hello guys and welcome. On today's video, I'd like us to discuss, how we solve differential equation by superposition approach. Obviously, we are dealing with undetermined coefficients right here, okay? So basically the idea is that like if you have a non-homogeneous equation, how are you going to solve that non-homogeneous equation? So let's say maybe for example, you have a non-homogeneous equation y double prime plus 2y prime equals x plus 1. Okay, so I'll start off small and build up from there. I just want you guys to get the idea of, particularly how do we determine the particular solution. So obviously, when we are dealing with a non-homogeneous equation, we expect its general solution. So the question will be that you should find the general solution. So keep in mind that the general solution of a non-homogeneous equation is given by y equals to y of c plus y of p, where y of c is the complementary solution that comes from a homogeneous part. So basically we'll get it from this side that like we'll form a auxiliary equation. From this we'll get m squared plus 2m equals 0. So from this we can simply find our y of c. So then now I think the most confusing part for most people is that how do we find our particular solution? Okay, so to find the particular solution there is something that you have to keep in mind. So what will help you to do that is basically the right hand side, which is basically g of x. So your g of x is what is going to help you to find your particular solution. So in this example, we see that our g of x is basically equal to x plus 1. Okay, g of x equals to x plus 1. What form of a function are we having? We are simply dealing with a linear equation. So that will give us an idea that our particular solution has to be of the form ax plus b. Okay, so yeah, that is the whole idea of how you find the form of a particular solution. So now maybe let me give other differential equation. Let's say you have y triple prime plus 3y equals to e to the x. Maybe before I go to e to the x, let's say we have x squared plus 4x. Okay, so now in order for us to know what is going to be our y of p, let's look at our g of x. We see that g of x is basically x squared plus 4x. Okay, so it is of the form of a quadratic function. So we see that our particular solution has to be of the form ax squared plus bx plus c. Okay, so that is the whole idea when you are using the superposition approach. This is how you determine the form of your particular solution. Okay, so particularly if you have, I don't know, maybe I'll just keep noting out g of x. You can have y double prime plus 2y prime plus 3 equals, now let's say e to the x, like that. So what is going to be, your particular solution, the form of a particular solution? So we see that g of x is e to the x. So now this implies that we expect our particular solution to be of the form, I don't know, a e to the x, just like that. Okay, so this is how you distinguish the form of your particular solution, because basically what is here is just a constant one. So you expect your particular solution to have a constant times that exponential function e to the x. Okay, so that is the whole basic idea. So now let's say maybe now g of x, I'll just note down g of x. Let's say maybe g of x was x e to the x instead of just e to the x alone. Then this will imply our particular solution is therefore going to be, what do we have on g of x? This is a linear function times an exponential function. So we expect the form of a linear function to be there, then multiply that with that exponential function that you are given. Okay, so that is the whole basic idea of how you find your particular solution when you're doing a superposition approach. Okay, so I'm not basically yet into solving any problems. I'm just trying to get you guys into the idea of how you distinguish what you call the particular solution form. Okay, so now once you have the form, then you can go solving for your unknowns, which is a, b, in that, and so forth. Okay, so let's example so you guys can get the jinx of what is going on. So let's suppose maybe for example they gave us a differential equation y double prime plus 2y prime equals 2x plus 5, then minus e to the minus 2x, just like that. Yeah, let's say they gave us something like this. Okay, so now we want to solve this non-homogeneous differential equation. Indeed, it is a non-homogeneous differential equation because g of x is not 0 right there. Okay, so now we know that, like I said earlier on, we expect the general solution to be y of c. Sorry, let me correct that. We expect it to be y equals to y of c plus y of p, just like that. Okay, so now let's find out what is y of c. To find y of c, we use this side. So basically, we're gonna have an auxiliary equation, m squared plus 2m equals 0. Okay, then we can factor out m, then we'll be left with m plus 2. That will give us 0. So basically m1 equals to 0, or m2 equals minus 2. So what do we have here? We're basically having m1 not equal to m2. So we are dealing with distinct real roots. So when we have distinct real roots, we know that therefore our complementary solution will just be c1 e to the power m1x plus c2 e to the power m2x. So basically our complementary solution is just c1 e to the power 0, which will just be 1 at the end of the day. So we just have c1 there, then plus c2 e to the minus 2x. Okay, so when I was giving you guys the form of a particular solution earlier on, I didn't, keep in mind that there can be solutions that will duplicate. So basically, since we are dealing or we are trying to find the general solution, we have to keep in mind that solutions are not supposed to duplicate themselves. Okay, so there is a way that we're going to get rid of that when the solution are duplicating. Okay, so particularly what I'm trying to emphasize is that when you are finding your y of p from g of x, the form of y of p, you have to pay attention to your complementary solution. So keep this in mind as well while you are doing that. So now let's go and see what is our g of x. We saw that our g of x is what is it? Let me just quickly check that. Is 2x plus 5. Then minus e to the minus 2x. So this is our g of x. So from this g of x, we see that basically our particular solution, we expect it to be, I don't know, this is indeed a linear function. So we expect it to have a linear function, ax plus b. Okay, so that is the expected thing. Then therefore, do not account for the negative sign. Okay, just put it there as a plus. Then we expect it to have e to the minus 2x. So e to the minus 2x, it has to be accompanied with a constant. Let's call that constant in this case c. Then c e to the minus 2x. So that is the whole basic idea. But then now, if you realize something about what I said earlier on, just a few minutes ago, that we have to pay attention to the duplicate of the solution. Okay, always keep in mind that you have to check if ever, when you're using the superposition approach, check if ever there is no solution that is being duplicated that you already have on your y of c. Because if y of p carries the same solution as y of c, then you therefore say you have found your general solution. That will be wrong. Remember that general solution is formed from the functions that are forming a fundamental set of solution, basically meaning that they are linearly independent of each other. Okay, so you have to keep in mind that as well. So that being said, now I want us to examine y of c. Y of c has a constant c2 e to the minus 2x. And then now from g of x, we see that our form of a particular solution has to be c e to the minus 2x. So that being said, we see that this will indeed be a duplicate solution. This solution is there and it's already part of y of c. So that being said, now we have to account for that duplicate. And how do we get rid of the duplicate? We are just simply going to multiply this by x. Okay, so indeed this is not the correct form of y of p, just only because of it has a duplicate. Okay, exactly, we still find it from g of x. Okay, I'm not saying that you no longer find your y of p from g of x. G of x just gives us the form of y of p. So it gave us this form. Now it is our duty to go and look out from y of c if there are not going to be any solutions that will be repeated there. Okay, so yes, to get rid of that duplicate, like I said, we therefore see that y of p has to be I'll leave this one out since I haven't said anything about it, but it also has a duplicate. If you have already seen that, that is fantastic. Then here we're going to say we multiply this by x, so we're going to have cx e to the minus 2x. Okay, so we have only checked this part. Now let's check the other part. The other part of y of c, it has a constant. Okay, so if we check our y of p initially, our particular solution, we see that there is also a constant b right there. Okay, so that being said, it implies there will also be part of a solution from y of p that is the same as the one in our complementary solution. We don't want that as well. So to get rid of that, now we are going to multiply our linear function as well by x. Notice that I multiply these things by x individually. I don't say that since this one is going to be duplicated, then multiply everything by x. No. You don't do that. You only multiply and account for that one alone, as I did here. Then I went back again to check. I find a constant, and that constant is relating to b. So then that is only when I'm gonna multiply with x this one as well. Suppose there at c1, maybe there was c1e to the x, like that. Suppose it was c1e to the x, then I wouldn't have any reason for me to multiply this one, because there wouldn't be any solution that is repeating from y of p that is already in y of c. I hope that makes sense. So basically now what we're gonna have is that we're gonna say we have ax squared then plus bx, just like that. Okay, then now we can therefore say what was our differential equation. Since we need to find out the value of a, b, and c, then it implies we have to derive this whatever so many times. So our given differential equation was the y double prime plus 2y prime equals 2x plus 5 minus e to the minus 2x, just like that, isn't it? Yes. Then now let's derive this. If we derive our y of p, we're gonna get that y of p prime, y prime of p is basically, we derive this function, we get 2ax plus I don't know, plus b, then plus or rather let me just already account for that negative. So this is just going to be, oh, hold on. So we can say plus. This is indeed a, when we derive this is a product of two functions. So we have to apply product rule. So we're gonna get plus c e to the minus 2x, then minus 2 um, cx e to the minus 2x, just like that. Okay, so that is the first derivative. So the second derivative of that, we see that since on our differential equation the highest order is 2, then we have to derive twice. Then the second derivative of y of p is going to be, this will just be 2a, the derivative of a constant is just 0, so that will go away. Then we're going to have minus 2c e to the minus 2x. Then now when we come here, I would like to keep this negative outside, then derive this. So here again, we apply what you call, let me keep out negative 2 instead. Then I derive what 2, I derive c x e to the minus 2x. So here, by product rule, I'm going to be left with c, then e to the minus 2x. I leave it alone. Then now I say minus 2, then I leave cx alone. Then I have derived, e to the minus 2x, just like that. So this is the second derivative. Can we clean up the room a bit? Yes, indeed, we can. I think so. Then we're going to get that y double prime of p is basically 2a minus 4 c e to the minus 2x, right? Then yeah, I've distributed the negative 2 in there, so I see this one and that one are like 10, so I added them up. That is how I got this. Then here I'm gonna get therefore plus 4 cx e to the minus 2x, just like that. So the second derivative is this one, the first derivative is that, and so forth. So now let's go and plug into our differential equation and equate everything up, so we can find our value, our unknown values of a, b, c. So we're gonna have here, we plug 2a on y double prime, we plug 2a minus 4 c e to the minus 2x, then plus 4 cx e to the minus 2x, just like that. Then we are done. Then we have plus 2 into I don't know what is y prime. Y prime is basically this one. So we are going to have 2a x plus b plus c e to the minus 2x minus minus 2 cx e to the minus 2x, just like that. Okay, then this has to be equal to 2x plus 5 minus e to the minus 2x. Okay, so now let's see if we can clean up the room here and group things accordingly, so we make our life a bit more easier than what it looks now. This is indeed a simple problem. So we have 2a minus 4c e to the minus 2x. I'll deal away first with the brackets, then plus 4 cx e to the minus 2x. Then now if you distribute this in there, we're gonna have plus 4 ax then plus 2b, then what is it, plus 2c e to the minus 2x, then minus 4cx e to the minus 2x, just like that. So this indeed has to be equal to 2x plus 5, then minus e to the minus 2x. Okay, so let's see if ever there are like terms, then what cancels away will cancel away and so forth. So we see that indeed this one plus, we have positive 4cx e to the minus 2x and negative 4cx e to the minus 2x. So this one and that one will cancel out. Okay, then what else will cancel out or add up as like terms? Let's look at this one now. If we check out this, minus 4c e to the minus 2x, it has a like term, this one. Okay, so we're gonna get from that, we have 2 negative 2c e to the minus 2x, just like that. Minus 4 plus 2, that will give us minus 2, then c e to the minus 2x. Okay, is that all? Yes, basically for this, that is all. Then what are we gonna have next? Then we can say plus this one, then I can say plus 4ax. Then now what I'm left with are basically the constant 2a and 2b. So I can therefore say plus 2a plus 2b. This has to be equal to 2x plus 5 minus e to the minus 2x, just like that. So now that I have things looking like this, I can therefore, compare this side with that one. So I see that e to the minus 2x, its coefficient this side is minus 2c. So I expect it to be equal to the coefficient this side, which is minus 1. So basically here we get that c equals half. Okay. Then now again, the coefficient of x this side, which is 4a, it should be equal to the coefficient of x that side, which is 2. So we see that a also has to be equal to half. So basically what is left off is the constant. So the constant 2a plus 2b, it should be equal to the constant that side, which is 5. Okay, but we already know a is half. So basically what we are going to have here is that 1 plus 2b must be equal to 5. So basically 2b equals to 4, then b is equal to 2. So we have our values of a, b, and c. So we have a, b, and c. Therefore, our particular solution, what is it going to be? Remember our particular solution, we had it here. This is the one. Okay. So we go and plug what is a, what is b, and what is c. So we have our particular solution was ax squared plus bx, then plus c x e to the minus 2x, just like that. So now we know the values of a, b, and c. So basically we have half x squared plus 2x plus half I don't know, x e to the minus 2x, just like that. So this is our particular solution. Therefore, now we can conclude that our general solution, which is given by yc plus y of p, is therefore y equals to, what was our complementary solution? Our complementary solution is this right here. We got it as c1 plus c2 e to the minus 2x. So we have c1 plus c2 e to the minus 2x. This was our yc, and now our yp is just this one. So we're just gonna have what? Plus half x squared plus 2x plus half x e to the minus 2x. Okay, so this is the solution to that problem. If you notice something, indeed, now we have this one and that one. So suppose here it's any constant, let's say for example 1, we would have e to the minus 2x, and then now it is indeed linearly independent from this one. So if we didn't account for the duplicate of a solution, this x wouldn't be there. So therefore we would have, we couldn't have this as our general solution. Yes, we have reached the end of the video. I hope this has eliminated a lot of confusion and has brought up, enlightenment and understanding of the superposition approach. Thank you so much for watching, and stay tuned for more videos. Bye.